Everyone, welcome to another video on my video series on teaching SQL for data engineering, data scientists, ML engineer, ML scientists, or applied scientists. In the last couple of videos, I talked to you about the selected statement, filtering the set of rows, aggregation using group by, ordering rows using order by. In the last video, we briefly go over join, inner join, left join, right join. Now today, I want to talk to you about perhaps one of the most important concepts in SQL. It's one of the most widely used concepts in SQL and is really common during the interview. And that's the concept of window functions. All right. So what does window functions, what do we do with window functions? There are certain tasks that you can do with window functions, which we are going to go over that in this video, like a lag, like a lead, create a lag version of a column, lead version of a column. You can create the row number like like a counter for that. You can calculate the quantile, percentile using window functions. However, one thing window function can do is that it can perform aggregation, similar to group by, but instead of aggregating the rows or collapsing the rows or reducing the number of rows, window function does not change the number of rows. This is fascinating. Window function, you see, remember in group by, whichever column you add in the group by statement, it should appear in the selected statement. In window function, you don't have such a response. Add as many columns as you like in the selected state. You have no problem. Okay. Now, here I am loading again. Let's take a look at the employees table again. All right. So to go over the window function, something that is very important to know that. So let's take a look at the count of this. We have 40 rows for this employees column. For now, let's forget about this query. I want to first go over this one. See, window function is defined inside the selected state. That's what you need to know. It's defined by the over clause and also partitioned by an order by. I will go over that. So the syntax for window function is over, partitioned by, and order by. Where does it appear? Inside the selected state. It does not aggregate the rows, and their columns do not need to have any constraint like a group by. They should appear in the selected statement or in the group by statement. There is no such a constraint. Okay. So to go over an example, let's take a look at this employees table. I want to calculate the total number of or the like a total salary per department, right? And I want to see how many record of each salary I have. Let's say, for example, how many salary record I have per department. Let's say, for example, here in this department ID, I can see 3 records of the for department ID 9. Here, for example, we can see 5 for department ID 6. All right. So here, let's motivate the idea with a group by. Remember, we look at the group by in one of the videos. So you are grouping by department ID. It should appear in the selected state. And this is aggregation. We calculate the sum of the salary, we call it the total salary, and then count of salary, count the number of times, but grouping by the department ID. Let's take a look at this. All right, you see what happens here. We had 40 rows, but how many rows do we have here? 11. It aggregates, it collapses the rows. This, you must understand this one for group by, right? But then it adds salaries per department as well. And then we have like number of records, we have 1. For this one, we have 2 records. For this one, for example, we have 6 records. Okay, great. Now I want to do something similar, like calculate the total salary using Windows function. All right, using Windows function, let's see what we can do here. I don't need this query here. Let's go to this query that I wrote here. You see, the window function is coming in the select state. But the beauty of it is that it doesn't change the number. You don't have to alter the number of columns or alter the number of rows, right? It works on a subset of rows. On any, you can define the subset of rows to be entire rows, or it can be subset of rows. Okay. So now, here I want to go ahead and choose all the columns. This is the employee state. I want to select every single column, And also I want to add one more column to the right of this table as a total salary. Can I do it? Yes, I can do it with Windows function. So let's take a look at that. Select employee ID, first name, last name, email, phone number, hire date, job ID, salary, manager ID, department ID. See every single column and sum of salary. Let's take a look at this. Sum of the salary. Calculate the total salary over what? This is define the subset of rows. Over define the subset of rows. Over what? Partition by. Think of a partition by like a group. So I want to calculate this over subset of rows. What defines this subset of rows? Which column defines this subset of rows? Partition by department ID. So calculate the total salary over the rows that have the same department ID. So read partition by as a pair, English word pair. Calculate the total salary per department ID. Now, when you calculate this, make sure you order it by department ID. So department ID, for example, 1, 2, like sorted. This order by is the same as the order by in the actual SQL statement. And then we call it total salary. All right, let's run this one. There you go. Look at this. I have the same number of columns, but then I have a total salary. I have a total. The number of rows is not changed. If you are in the department ID 2, let's take a look at the salary column, this column. I'm looking at this column. So here, because we have only one record, we get 4,400. Here we have two records, 13,000 plus 6,000, we get 19,000. Both of them are 19,000. You don't have to aggregate the number of rows. Here we have how many? 1, 2, 3, 4, 5. 5 or 6. Okay, so you add them all together. When you add them, you get 24,900. If you add all these values, all of this value, if you add all this value in the salary column, you get 24,900. All right. So that's what the power of the window function. It's defined by over, partition by, and order by. Order by is ordering the rows when they show the result. Partition by is saying that how do you want to group the rows? Okay. And remember, you don't have to include any of them per se, right? You don't have to if you don't include partition by, you're not really partitioning the rows. It's operating on entire rows. As a matter of fact, let's take a look at this one. I'm going to copy this. Let's go over this example. Okay. And I'm going to remove the partition by. All right. Let's take a look at it. All right. You see, guys, when you remove this partition by, what's going to happen here is that it operates on the entire rows. So when you have here 4,400, you just have 4,400. When you get to the these two elements, 13,000 and 6,000, you get 13,000 plus 6,000 and 19,000 plus 4,400, you get 23,400, right? And then when you add them up to all these values, all these, you get 48,300. In a sense, it's like a cumulative sum. So this one is similar to cumulative sum. Cumulative sum. So something like this. When you have 1, 2, 3, 4, cumulative sum will be what? 1, 3, 3 plus 3 is 6, and 10. Okay, so window function can do that. So partition by is not required, depends on what your task. This question is asked all the time in the interview. It's very hard to imagine you take an interview for the data science related to SQL and the window function is not appear. That's how important the window function is. All right. Another question that is very common during the interview is the functionality of lag and lead. All right, let's explain this. I have an explanation, I think, here. Let's go over this lag and lead. You see, when you have a column or time series data or series of a data that is, let's say, we want to create a lag version of that. Lag 2 version, lag 1 version, lead 1 version, lead 2 version. So in a sense, let's say that your values are 1, 2, 3, 4, 5, 6. If I tell you that, can you create a lagged 1 version, a version that that is one value behind this values all the time. How do you do that? So if this is x 1, 2, 3, 4, 5, 6, x lagged by 1, I will put a 1 here as well, is what? You shift this one to the left, in a sense. So if you shift 1 to the left, what's going to happen? Null value, because there is no value prior to 1. So you get the first one missing one. Then 2 become 1, 3 become 2, 4 become 3, 5 become 4, and 6 become 5. And when you create a lead 1 version, you shift this one to the right. So what's going to happen here? 6 become null, because there is no number after 6. 1 become 2, 2 become 3, 3 become 4, 5 become 4 become 5, 5 become 6, and 6 become missing one. This question happens all the time, asked all the time in the Can you create a lag 1 or lag 2 or lag 3 version of this column? Sometimes people go beyond that. Can you subtract this? But for now, we want to focus on creating lag version. All right. Absolutely. There are two functions in window functions, two important ones. One of them is a lag. This is a column number, column, and this is how much lag you want to include. How much lag. The same thing you can use for a loop. So the operation that I described here is lag 1. So here it's going to be 1. Okay. So I want to create a lag 1 version of the cell and then add it to my page without aggregating across the rows. This operation, I'm telling you, cannot be done with group by. Group by is very limited compared to window functions. All right, let's take a look at this. So I choose as first name, last name, department ID, salary, and then lag salary 1. So if you look at this salary guys here, let's only focus on this column, salary. Only focus on this, right? As a matter of fact, I want to make it very easy for you guys. Select salary from employee. Let's limit by 10. Let's take a look at this together. All right, this is salary. So it would be better if I order by as well. Order by salary limit. Yeah. By default, SQL okay. So if I want to create a lag 1 version of this, what's going to happen? Remember, this is 1, 2, 3, 4, 5. We shifted 1 to the up. We shifted 1 up. Right here was left, one here shift 1 to the up. This value become missing value. This one become missing value. The 2600, this number 2 become 2500. This number 3 become number 2, 2600. This become 2700. This become 2800. This become 2900. This become 3100. This become 3900. Each value become the value above. That's a lag 1 version. You can do it easily within that. Let's take a look. So I want to calculate the lag 1 salary per department ID. Okay? Easily partition by department ID. Let's take a look at this. So select first name, last name, department ID, salary, lag 1 salary. Please bring lag 1 salary over what? What subset of rows? How do you want to group rows? I want to partition them by department ID and then order them by department ID. Order by department ID. And then call it salary lag 1 from employee. Let's take a look at this. There you go. Guys, focus. Just focus on the salary lag 1. Let's just focus on this. Just focus on this. All right. So we are in department ID 1. We have only one record here. What's going to happen lag 1? Missing value, because we have only one record. There is nothing really. We push it up, we get missing value. We are in the department ID 2. What are the records? 13,000, 6,000. What's going to happen to the first value? Always missing value, because you shift the 13,000 up, you got missing value. Now you shift 13,000 up, is going to be here, right? It's going to happen here. So this value is going to replace by 13,000. Now let's go for this one. This value. All the way this way. I'm sure you, let's take a look at that. The first value 11,000 become missing value. Then the second value becomes the first value 11,000. The third value becomes second value 3,100. The fourth value 2,900 becomes this one. So in a sense, a lag version of that. the second value is the first value of the second value. So it's a shift. Okay, so it's actually very, very, very important that you consider that. So what can happen in the second value here is the first value of this one. So that's how you can calculate. You can do the same thing with the lead value. I wrote something here for the cumulative sum. Let's go over that together. Cumulative sum is something we discussed here. This also happens in the interview a lot. A lot of questions can be asked during using window functions. So cumulative sum is the idea is that it's like a CDF. So you have a series of number 1, 2, 3, 4, 5, 6, right? You write the first number. Each number is the sum of the number itself and all the numbers in the past. So the number here is going to be 2 plus whatever we had in the past, 3. 3 here is going to be 3 plus what we had in the past. 3 plus 3 is 6. 4 is 4 plus what we had, 6, 10. 5 plus 10, 15. 6 plus 15 is 20. All right. That's what I'm going to calculate. What you can do here, you can say the select, for example, department, or let's take a look at the employee ID. Let's see what employees, let's see what sort of columns we have from employees. Use something more innovative this time. All right. First name, last name, job ID, department ID, manager ID. You know what? Let's do something interesting. We can do it from first name and last name. Because because we want to calculate the cumulative sum by first name and last name. All right. So what we're gonna do here is that, so when I say by first name and last name, means that these rows are used for two partitions. Like the entire cumulative sum over the whole table, whole data. In group by you get one number. Guys, in group by you get one number. In window functions, I want to get a column, maybe some of the values will be the same, maybe, right? Which is not the case because you add one number to the all the result of the past values. But you get what I'm trying to say that you get a column of that. So you get a vector instead of one value that you get from group one. All right. Let's say select first name, last name, salary, some salary, over, I want to say order by first name. Let's do this. From employees. All right. Let's take a look. Let's take a look at that. Can you be? Let's take a moment and look at this one. Let's take a moment and look at the The first one is 8200. Right. The next one is what? So you take these two. What do you get? 9,000 plus 8,200 plus 3,100. You get this 20,000. So these two are the same. I agree. These two are the same. But they still get repeated. It's not like group by that we aggregate to be one number, right? This might be very, very useful. Now we add it to this. So you see that they have the first name. The first name is Alexander. That's why these two are repeated like that. Right? These two rows are considered the same because we partition or order by these two. So they are considered to be same. So if I order by last name, okay. Now this is better. This is exactly cumulative sum because order by unique things. So let's take a look at only these columns, these rows. You have 8,200, 8,200. If it's the first number, it's added by nothing. Then we have 9,000. 9,000 plus 8,200 becomes 17,000. 3,100 plus 17,200 becomes 20,300. Plus 3,900, 24,200. Plus 6,000, 30,000. That's a cumulative sum. This is one of the most challenging questions they ask in the interview. You see how easy is that? We can answer using window function. So There are a lot more you can do with window functions. You can calculate the quantile, percentile. You can do a lot of examples with window function. You can combine it with the join, all sorts of stuff, which we're going to cover it later on. I would conclude this video because it's getting really long for now, but you see how useful is window functions. Please leave any comment if you have a question, and I do my best to answer your question. Remember, window function is one of the most important topics you need to know. And like always, if you like this video, like and subscribe to the channel, share this with your friends, and I'm looking forward to see you all in the next video. Thank you so much.